We looked in a previous video at what happens when you raise a number to a power. We looked at positive powers and we've looked at negative powers. What we're going to look at here is when you raise a number to a fractional power, a power that is not an integer. We're going to start off with this one, 9 raised to the power of a half. Before we do that, just a quick recap of this indices rule that we worked out in a previous video, where if we take a number and raise it to the power n, multiplied by the same number raised to the power m, the result is a to the power of n plus m. When we're multiplying, we add the powers. So if we had 9 to the power of a half, I'm going to say is, let's say we multiplied 9 to the power of a half by itself, 9 to the power of a half, equals, well, from our rule here, we know that we add the powers because we're multiplying. So a half plus a half equals 9 to the power of 1. And 9 to the power of 1 is just 9. So something multiplied by itself equals 9. Well, we know that that must be the square root of 9. So actually what we're saying, which is 3. So we could say that the square root of 9 times by the square root of 9 equals 9. Or 3 times 3 equals 9. Interestingly though, when you compare these two ways of writing out the same sum, we're saying that 9 to the power of a half equals the square root of 9. So 9 to the power of a half equals square root of 9. Why? Because here we've got two numbers to the same number multiplied by itself equals 9. And we've just rewritten here, the same number multiplied by itself equals 9. So this has to equal this. Okay, let's have a look at another example. Supposing we said 64 raised to the power of 1/3. Just like we did over here, we're going to think, let's assume 64 to the power of a third, if we were to multiply that by itself and by itself again, using our rule, 64 to this power of a third times itself by itself, well, we add the powers, a third plus a third plus a third equals 1. 64 to the power of 1 equals 64. But we also know that if we're taking a number and multiplying itself again equals 64, well, that number must be the cube root of 64, because that's the definition of a cubed root. So we can rewrite this as the cube root, notice the 3 in front there, the cube root of 64 times by the cube root of 64 times by the cube root of 64 equals 64. And just like we did in our first example, comparing the numbers that we're multiplying by itself again, in the first and in the second example, we can see that 64 to the power of 1/3 equals, this time, the cube root of 64. Notice that this cube here corresponds to the 3 in the fraction. Just like the square root here, there's a little 2 we don't write, but the square root corresponds to the 2 in the denominator of this fractional power. So actually we can write that more generally like this. If we were to say x to the power of 1 over n, well, that just equals what we call the nth root of x. And that's our general case, our algebraic case at looking at fractional indices.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.